So in this video, we're going to be looking at multiplying whole numbers. The prerequisites for this video would be the last couple of videos in this series, and so we need to at least have an understanding of addition and subtraction and the different properties and methods that we use to solve both worded problems and just numerical problems. So, what is multiplication and why is it useful? So obviously addition can be used if we're counting things. So we could count all the coins on the screen and we could just begin at 1 and count all the way up. There happens to be 24. And so another way we could do this is we could kind of divvy them up or put them into rows or columns or groups of some sort. And so a couple of ways we could do that is we could put them in 8 groups of 3 coins, or we could put them in 3 groups of 8 coins. Effectively, rather than saying 1, 2, 3, and so on, we could just say, okay, now we only have to count the groups of 3. And so we would count 8 groups of 3, and then we would say 8 times 3, and we would get 24. So we would go 8, 16, 24. And so that's the use of multiplication, really. So it's like repeated addition. It's grouping things together before we multiply. So rather than adding by 1, we're basically adding by groups of 3 or by groups of 8. So if I was going to do by groups of 3, we could say 3, 6, 9, 12, and so on and so forth. And so rather than counting 1, 2, 3, 4, we're kind of able to do it a bit more efficiently. And so that's the purpose of multiplication. In terms of what each number is called, just like we said that in addition we had the addends, well, in multiplication, each number being multiplied is a factor, and the result is then called a product. So if we had the coins here, we would have 3 and 8 being the numbers being multiplied together, so they're the factors, and 24 would be the result. So moving on to the multiplication notation. So the operation is obviously multiplication, and there's 3 real ways that we can represent this. So the first is just your cross, really. And so it kind of looks like an X. The next one is a dot, and this becomes really useful when we start moving into algebra and you have variables like x's, so you don't want to get confused. And the same thing there for brackets. So I use brackets a lot when I'm substituting values in for variables. We'll discuss that later, but you can see all 3 of these. And so if you look in the expression column, you'll be able to see these 3 examples. Really important to understand that they all mean the same thing. So they can be read as 3 times 8, and the result of that would be the product of 3 and 8. So going through a couple of examples, we want to translate from math notation to words. So the top one would be 7 times 6, right? So we've got that 7 multiplied with the cross operator by a 6. So then we've got 12 times 14. So the dot means the exact same thing. And then same with question C, which is 6 and 13. So 6 multiplied by 13. So a couple of really important properties to understand before we start actually using multiplication. So the multiplication property of 0, it states that the product of any number and 0 is going to be 0. It's like saying that we have 0 groups of 8 or 0 groups of 100 or 0 groups of 1000. It's still just 0. We don't have any of those groups. And so generally we see A times 0 equals 0 and 0 times A equals 0. And so this kind of leads in to the commutative property. And so the commutative property says that we can swap around the factors as we see fit. So, a couple of examples. Multiply A, which is 0 times 11. So 0 groups of 11, well, there's just going to be 0. 42 groups of 0. Well, 42 groups of 0 would just be 0 as well. And so this kind of proves that property of 0. And so what happens when we multiply any factor by 1? Well, there's something called the identity property of multiplication. And so this identity property says that the product of any number and 1 is just going to be the number itself. And so A times 1 equals A, and 1 times A also equals A. And so generally what you'll see is that we could put 1 times 1 times 1 times 1 times A. That all just means A. And so a lot of the time you won't see those ones in algebra. And so very important that you just remember that one group of something will always just be that thing. It's like if I said there was one class of 25 students, how many students were there? Well, there's just 25. So a couple of quick examples. So we've got 11 times 1, and so there's 11 groups of 1, and so there would just be 11. And same thing for the second one. We've got one group of 39, so we could say there's just 39. Okay, as I was discussing before, we also have the commutative property of multiplication. And so all this says, in essence, it's kind of like the addition commutative property. And so it just means that changing the orders of the factors doesn't actually change the product or the result of that multiplication. And so you can see here that if you have a number A and a number B, and you multiply them together, it doesn't matter whether the B comes first or the A comes first, it's going to end up with the same resultant product. So just briefly, an example here. So if we have 8 groups of 7, we get 56. And so if we get 7 groups of 8, we also get 56. So it doesn't matter which way we put the factors, as long as they're both there, then we get the same result. So now that those properties are out of the way, we actually have to learn how to multiply two numbers and find the product. And so as I usually do, there's some steps here outlined for you. I recommend writing these down, so as we approach the practice problems, you can have these handy. And I would recommend doing the practice problems, maybe seeing one example and then having a go yourself. And so that's the best way to learn. Doing by practice is a lot better than just listening to me talk. And so what are the steps? Well, step 1 is to write the numbers, so each place value lines up vertically. This should feel pretty familiar from addition and subtraction. It's the same concept. Then we want to multiply the digit in each place value. So we work from left to right, starting with the ones place in the bottom number. Sorry, it should be right to left. And so we want to multiply the ones digit of the bottom number by the ones digit of the top number, then by the 10 digit, and then so on. And so if a product in a place value is more than 9, we carry to the next place value. That should also feel very similar to addition, remembering that this is repeated addition. And so then we would write the partial products, lining up the digits in the place value with the numbers above. And so when we head to the tens and we start multiplying that by the top number, then we would insert a 0 and then continue doing the same thing. And the same thing for 100s. When we get there, we would end up putting 2 zeros below. And then ultimately what we do is we end up doing addition at the end, where we add all these partial products together. So they're partial products because they make up part of the answer. When you add them together, you get the complete answer. And so now we're going to multiply two numbers that have the tens place and the ones place in them. So remembering it doesn't matter which order, you can put the largest number on top or just go from left to right. And so I would just go from left to right. So I put 62 up top, and then a multiplication, and then 8 and 7. So we just put our line underneath, and then we go from right to left, starting with our ones multiplying by our top one. And so we get 7 times 2, which is 14. So we put the 4 there, and then we put the 1 on top. So this number gets added after we do the result of the next. So it's really important to understand that. So we get, the next step would be 7 times 6. And so we get 42 there, but then we add that 1. So we get 43. So we get 434 for the first. So what that is saying is 7 times 62 is going to be 434. The next step, we'll be doing this in the tens place. And so what this is really going to do is 80 times 62. So we want to put the 0 down because we've gone over to the next place. And so then we go 8 times 2, which is 16. Now we want to carry this one. I would just cross that out initially and then put another one there if we're going to do it again. And so then we get 8 times 6, which is 48. And then we add 1, so we get 49. And so ultimately what we get is 434 in the first row and then 4,960 in the next row. So at this point, we need to add the resultant product together. And so we just do this normally. So this is why addition was such a good prerequisite for this lecture. And so we get 4 plus 0, which is just going to be 4. 3 plus 6 is 9. 4 plus 9 is 13. And then we'll carry that 1 just like normal addition. And then we get 1 plus 4, which is 5. And so we should get 62 multiplied by 87 is 5,394. All right, a couple more examples here. So we've got 47 multiplied by 10 and 47 multiplied by 100. So with part A, 47 times 10, we just want to set up our multiplication columns. So we go 47 and 10, put our little multiplication sign so the teachers or whoever knows what we're doing. We put our line underneath and we just go 0 times 7, that's 0. 0 times 4 is 0. So now we just go to the next row. And so remembering, because we're moving to the tens place now, we have to add a 0. And so then we go 1 times 7, which is 7, and 1 times 4, which is 4. So there we've got our two partial products, and then we want to add those together. And so we go 0 plus 0 is 0, and 0 plus 7 is 7. Then we've just got 4. We haven't got that added together, so we can just carry that down. And so the ultimate answer to that is 470. So for B, we're doing the exact same thing, but this time we want to do 47 times 100, remembering to line our places up. And so we get 0 times 7 and 0 times 4, so we've just got two zeros there. Then we want to add a 0 here, and then we go 0 times 7, 0 times 4. Well, that's both going to be 0, because remember, 0 groups of anything is always going to be 0. So this is our multiplication property of 0, right? So you should be able to identify that all of those zeros are going to multiply and just become 0. And so finally, because we're moving to the hundreds place, we need to add two zeros. And then we go 1 times 7, which is 7, and then 1 times 4, which is 4. And so ultimately we need to add all these together, which is quite easy since most of them are zeros. So 0 plus a bunch of other zeros is just going to be 0 for both of those, and then we get 47. And so 4,700 for B and 470 for A. Now I'll give you a quick second, see whether you can spot a pattern with those. So hopefully we were able to spot the pattern. Really for A, we've done 47 times 10, and we've gotten out 470, which is basically 47 and then a 0 at the end. Now, for 47 times 100, we've ended up getting 4,700, which is basically 47 with two zeros at the end. So what you'll notice is, for A, we had 1 0, for B, we had two zeros, and those come from the hundreds. And so a good way of knowing whether you understand this concept is that if you have like 47 times 1 million, you should end up with 47 plus all of these zeros trailing behind. And so it's really important that you kind of understand that. That'll make a lot of things simpler. And so realistically, another way to like kind of understand this would be if you go 47 times 10, I know it's a bit beyond our scope at this point, but there's really a little decimal point there. And so we're moving that little decimal, and then we just add a 0. And then for each extra 0 on the end, you're just moving that decimal one more place. All right, now a bit of a more difficult problem. So we've got 354 multiplied by 438. So we start by lining up our columns. And so realistically, multiplication doesn't really become any more difficult, but it can just look or feel a bit more difficult in the sense that it's the same process, but if you have to keep repeating it, there's more room for errors. And so we just start from right to left and we multiply. So we do 8 times 4, then 8 times 5, then 8 times 3, and then we add a 0 to the next row, and then do the next thing for the 3 times 354. And so let's do that now. So we get 8 times 4, which is 32. Carry the 3. 8 times 5 is 40, plus 3 is 43. Carry the 4. 8 times 3 is 24, plus 4 is 28. Now we put a 0 in the next row because we're going to the tens, and then we go 3 times 4. It's probably good to cross these out as well. 3 times 4 is 12, carry the 1. 3 times 5 is 15, plus 1 is 16. So carry the 1 there as well. And then 3 times 3 is 9, plus 1 is 10. And we just put the 10 there because that's the last place we can't keep carrying over. So we're going to the hundreds column, which means we need to add 2 more zeros to the next row. And so we go 4 times 4 is 16, which we can carry that 1. Probably should do another one. And so then it would be 4 times 5, which is 20, plus 1 is 21. Carry the 2. And then 4 times 3 is 12, plus 2 is 14. So that we get 14 at the end. Now we're adding all these together. So we need to put another line there. And then we go 2 plus a couple of zeros is going to be 2. 3 plus 2 plus 0 is 5. 8 plus 6 is 14, plus 6 is 20. Carry the 2 up here. 2 plus 2 is 4, plus 0 plus 1 is 5. 1 plus 4 is 5, and then 1. And so we end up with 155,052. Okay, another example, remembering our notation. So we can have one bracket, we can have both brackets, we can have the other one in a bracket and the other one out of the bracket. It all means multiplication. And so we set this up exactly like last time. So we go 896 times 201, a little line underneath. And we go 1 times 6 is 6, 1 times 9 is 9, 1 times 8 is 8. Then we add our 0. 0 times all this is going to be just 0. And I know I'm going a little faster now, but you'll be picking up speed at this point, I hope. And so 2 times 6, well, we first got to add the 2 zeros because we're in the hundreds place. Then we go 2 times 6 is 12, carry the 1. 2 times 9 is 18, plus 1 is 19. Then we carry that 1. Then 2 times 8 is 16, plus 1 is 17. And so then we add all those together. So we'll just get 6 plus a couple of zeros is just 6. Same thing for 9. 8 and 2 is 10. So we carry the 1, 1 plus 9 is 10, carry the 1, 1 plus 7 is 8, and then we carry the 1 down. And so we end up with 180,096. All right, so now moving on to multiplying with multiple factors. So all of our problems so far have just been 2 factors. And so there's not really too much of a difference here. What we're going to do is we're going to multiply the first 2 numbers. You can pick whichever of the first 2 numbers you want to multiply. And then we multiply that product. So the answer we get from multiplying those 2 factors together, we multiply that by the next factor. And so you can see an example here. If we have 8 times 3 times 2, we do 8 times 3 first, which is 24. And then we can multiply that by 2 to equal 48. Another example would be we could do 3 times 2. So the second 2 numbers, which would be 6. 6 times 8, which would be 48. And so both ways get us to the same answer. Okay, so now we want to start thinking about worded problems and application problems. And so we really need to get a good understanding of what word phrases correlate with multiplication. And so we can think of things like times, product, and twice. So, or a bunch of other ones really that kind of, so 4 times or some kind of concept or word that relates some kind of grouping by a bunch of other groups. And so we can get things like 3 times 8 or the product of 3 and 8 or twice 4. And you can see in the right hand on the expression side, we've got a bunch of different notations. They all mean the exact same thing. And so just getting used to having those phrases as well as those expressions is very important. Right, so now a bit of practice. We can translate and simplify the product of 12 and 27. And so what are we trying to find here? So if I was looking at this, I would automatically have a look and I'd see what word phrases I can see immediately that point me in the direction of what operation I'm supposed to use. And so a product relates to multiplication. So that says to me that we're looking for the multiplication of 12 and 27. So we want to find 12 times 27. And so we just do the exact same process once we've worked out what we're supposed to do. And so we get 7 times 2, which is 14. And then 7 times 1, which is 7, plus 1 is 8. And then we get 2 times 2. So we add the 0, then 2 times 2, which is 4. Then 2 times 1, which is 2. Now we add these together and we get 4, 12, and then 3. So we end up with 324. And so that's how we would translate. Translate is the part where we're finding out what multiplication we're trying to, or what operation we're trying to use. And so multiplication would be the translation part, and then the simplification part would be doing the actual problem. So finding the answer of 324. Another example here, so translate and simplify twice 211. So a bit of a weird phrasing here, but if I'm making two groups of 211, which is what twice means, we know we want 2 times 211. And so we can go 2 times 211. And then we want to multiply. And a key tip here would be always put your smallest number on bottom if you can. That way I don't have to worry about adding zeros and moving over places and then adding all of it together. For this example, if I only have one place, then I don't need to do any addition after this. This will find me the answer. And so we get 2, 2, and 4. And so we end up with 422. So how do we multiply whole numbers for applications? Well, as per the last couple of videos, I indicated this process that I expected would be very helpful for people to use as we start talking about worded problems and application problems. And so really what we want to do is we want to determine what we're looking for, write a phrase that gives the information to find it, and then translate that phrase into math notation and simplify. And then finally, we want to write a sentence to answer the actual question. And so we've actually worked through all of this in the previous videos for addition and subtraction, and the same kind of skills will correlate with multiplication. So Daniel bought 4 sheets of stamps. Each sheet had 20 stamps. How many stamps did Daniel buy? So what are we doing here? Are we looking at adding? Are we looking at multiplying? Are we looking at subtraction? Well, if we've got 4 sheets and each sheet had 20 stamps, that means we have 4 groups of 20. And so whenever we're thinking of grouping things or adding repeated addition via grouping, we know it's multiplication. So each sheet had 20 stamps. So there's that 20. And then we had 4 of those sheets. And so we just need to do some simple multiplication here. It's a very simple problem. And what we end up with is 80. And so finally, the last section we have to do is we have to actually write the worded answer. And so we would write something like Daniel had 80 stamps. Or Daniel bought 80 stamps, or whatever phrasing, just to show that you can actually translate it back from a mathematical answer into something that's easily accessible for people that maybe aren't mathematically inclined. So Lily is planning to build a patio. She'll have 8 rows of tiles with 14 tiles in each row. How many tiles does he need for the patio? So I'd like you to have a go at this one on your own, but I will start working on it. So my first thoughts are, okay, we're looking for the numbers, really. And so if we have 8 rows with 14 tiles in each row, that says to me that we have 8 groups of 14. And so immediately I think of multiplication. And so I'm just thinking we'll do 14 times 8, and that'll find out how many tiles we actually need. And so we go 8 times 4, which is 32. Carry the 3, 8 times 1 plus 3 is 11. And so we need 112 tiles. And so we would say something like Lily needs 112 tiles for the patio. All right, so another application which is very, very common, probably the most common that it deserved a specific section of this video, was area. And so when we're thinking of area, we're thinking of the amount of surface that's covered by some shape, and it's measured in square units. And so it doesn't matter what the shape is, we can still find an area for it. And the basic area that we'll be looking at today is just your squares or your rectangles, something where there's a fixed length which is the same on both sides, and then a fixed width, which is the same on the opposite two sides. And so in terms of what a square unit is, it's just if we have a square, and let's say this square is 1 centimeter here, and this one's 1 centimeter here, that means that's 1 centimeter squared. So 1 centimeter times 1 centimeter, we get 1 centimeter squared. Remembering that a square is something multiplied by itself. So if we have a centimeter by a centimeter, we're going to get a square centimeter. And so that's what we're looking at in terms of area. How many of those squared centimeters or squared meters can we fit into that specific shape? And so to find the area, what we do is we multiply the length by the width. And you can see that on this shape. So if this was the length and this was the width, then we would multiply these two together and we'd end up with what this is, which is 1 centimeter squared. If it was larger, maybe it was 4 here and 2 here, then we do 4 times 2, which is 8, and then we have 8 centimeters squared. So onto an example problem. Jen's kitchen ceiling is a rectangle that measures 9 meters long by 12 meters wide. What is the area of Jen's kitchen ceiling? So for rectangles, we know that our area, we'll call it A, is equal to length, L, times width. And so we do have the measurements, but if you want a visual here, we can draw a rectangle, a rough rectangle. And so if we have 9 meters long, let's go 9, and we have 12 meters wide, then we know based on this area formula, what we'll have to do is multiply, and then we'll be able to find all of this area in square meters. So meters, because we are multiplying a meter by a meter, which is a square meter. And so here we'll just set this up. So we go 12 times 9. We go 9 times 2 is 18, carry the 1, and then we get 9 plus 1 is 10. And so we end up with 108. So we could say the area of Jen's kitchen ceiling is 108 meters squared. And so we always put our squared up there exactly like that. So this is a really, really important concept. We'll have some more videos on area because there's a lot more to it than this, but this is a brief example that we can go through, and it'll kind of get you warmed up for later concepts. So that's been our video on multiplication. We've went into quite a bit of depth there. Hopefully you've got a good understanding. We'll be releasing a lot more practice problems, and so that's something to look forward to. But I would recommend just having as much of a play around with different math problems, both worded problems with multiplication and just numerical problems, and just getting a feel for how things work. You could listen to me talk till the cows come home, but it's really important to get in there and get your feet wet with actual problems. And so if you've liked today's video, just give us a like, comment, and subscribe, and we'll see you on the next one, which will be division.